Hi, this is Mrs. Russell. Welcome to my session. Today we are going to be looking at graphing and specifically graphing linear equations. So a linear equation, if you look at this, the key word in linear is the word line. So when we graph a linear equation, we're going to be graphing a straight line. And the general form for any equation that's in linear form is y equals mx plus b. So m stands for your slope, and b is the y-intercept. So there's a few ways that we can graph, but before we get into graphing, we're going to talk about how do we know if a point is a solution to an equation, or is this point on the line? So one thing we could do would be to graph the line and see if the point 2, 6 is on the line y equals, 5x minus 4. Or another thing we can do is we can test the point. So remember in the point 2, 6, 2 is your x value and 6 is your y value. So we're going to take this equation and we're going to sub in x and y and see if it works. So y again is 6. We want to know, does that equal 5 times x? Well, x is 2 minus 4. So if we do 5 times 2, that's 10 minus 4 is 6. So yes, it does equal 6. So that means that the point 2, 6 is a solution to 5x minus 4. All right, so this one, if you want to go ahead and pause the video, you can try it on your own, and then we'll come back and do it. All right, so hopefully you were able to try this on your own. So again, they want to know, is the point 3, negative 4 a solution to y equals 4x minus 8? So our x value is 3, our y value is negative 4. So we're going to plug in y is negative 4, and we want to know, does that equal 4 times x, which is 3, minus 8? So is that true? So we have negative 4 equals, if we do 4 times 3 is 12, minus 8 is 4. So does negative 4 equal 4? No, it does not. So that means that 3 negative 4 is not a solution to that equation. All right, so now we're going to look at graphing these lines. So there's a few ways that you can do it. The first way we're going to talk about is just to make a table. So usually when you make a table, you want to test a few points. So usually I recommend doing a couple negatives. You can pick what you want these to be, a 0 and a couple positives. So you can pick the x values. Again, I'd recommend doing some negatives, 0, and positives. So then all you're going to do is you're going to plug those values into your equation. So if negative 4, we would do 2/3, and we're going to replace x with negative 4. So we do 2/3 times negative 4 plus 4. And see what that comes out to be. Well, that'd be negative 8/3 plus 4. Negative 8/3 is negative 2 2/3 plus 4, and that would be 1 1/3. So if we plug in negative 4, we get 1 1/3. And then you're going to repeat this process for each number. So now we're going to do negative 2. So we would do 2/3 times negative 2 plus 4. Well, that's negative 4/3 plus 4, which is negative 1 1/3 plus 4, which is 2 2/3. 0 is easy. 2/3 times 0 plus 4 is 4. 1, 2/3 times 1 is 2/3 plus 4 would be 4 2/3. And then 4 would be 2/3 times 4 plus 4, which is 6 2/3. So now you can take these points and you can plot them. So I'm going to go to a new sheet here so we can graph these. So we're going to go between the two. Oh, sorry. So let me get back into this PowerPoint here, or this presentation. All right, so we were going to graph that table. So first thing I'm going to do is, I forgot the nuts. We had -4, -2, 0, 1, and 4. This one was 4. So I'm just going back to this table. So -4, so we had 1 1/3, 2 2/3. Now you should really do this on graph paper. Actually, you know what? Let me change it to a grid. So there. So we can plot these points. So we have -4, 1 1/3. So you go to -4, 1, 2, 3, 4. 1 1/3 would be about right there. -2, 2 2/3. So you go to -2, 1, 2 2/3 is about right there. 0, 4. So 0, 1, 2, 3, 4. 1, 4 2/3. So 1, 1, 2, 3, 4 2/3. And then 4 would be up off my graph. But you can see that these points, if I connect them, they make a nice line, which it should because this is a linear equation. So one way to graph is to make a table. Another way to graph is to use slope-intercept form. So this is often easier than making a table if you understand how to use slope-intercept form. So we have 2/3 x plus 4. So if you recall, the 2/3 is your slope, and the plus 4 is your y-intercept. So if we're going to graph using slope-intercept form, the first thing that you're going to plot is you're always going to plot your y-intercept. Well, that was +4. So that means we're going to go on the y-axis to 4. 1, 2, 3, 4. So there's that point. And then from there, you're going to do the slope. Well, the slope is 2/3, which is in fraction form. So slope, if you remember, is rise over run. So we're going to go from our y-intercept and we're going to rise 2. So 1, 2. And we're going to run 3. So 1, 2, 3. So it's going to be up here. And I hit share because I went off my graph. So I need to, it's taking a minute here, it's thinking. Sorry about this. All right, I'm going to close out and hopefully. All right, so I'm getting back in, so hopefully this will open up. Okay, there we go. All right, so I'm going to go back and I'm going to change my graph, move it down a little bit so I don't have that issue again. Okay, there we go. So we're going to graph. So here's my x-axis and my y-axis. So again, we're going to plot the y-intercept, which was 4. 1, 2, 3, 4. And then the slope was 2/3, which is rise over run. So that means we're going to start at our y-intercept, which is 4. We're going to rise 2 and run 3. So that would put this point right here. And then we can take those 2 points and connect them, or you could make a third point by going rise 2, run 3. It's going to go off the graph for me. Or I know another point would be, instead of going up 2, right 3, I could go down 2, left 3. So there would be another point and connect those. And that would be another way to draw that line. All right, so here we have another equation. So we'll do this one together and then I'll have you try one on your own. So again, in this equation, our slope is 3/4. Our y-intercept, now notice this is a minus, so you have to take that with it. So our y-intercept is actually -5. So if we were going to graph this, we'll plot our xy axis. I'm actually going to move it up here. Here's our x-axis, y. So our y-intercept is -5. So that means I'm going to go and plot 1, 2, 3, 4, -5 is right there. And then from there, I'm going to use my slope, which is +3/4. So that means I'm going to rise 3 from my point, 1, 2, 3, and run 4, 1, 2, 3, 4. So there's 2 points. I can connect those. Oops. To get the graph of that equation. All right, now here, if you want to pause the video and try this one. Now, just before you get started, though, I'll point out that the slope here is -3, and notice that is not in fraction form. But you could put it in fraction form by making -3, -3/1. So use that as your slope and try to graph this. Pause the video and then come back when you think you have it. All right, so hopefully you were able to graph this. So again, we talked about your slope is -3/1. Your y-intercept is 4. So here's our xy axis. So if you were going to graph this, the first point you're going to plot is the +4 because that's your y-intercept. So 1, 2, 3, 4. Now your slope is -3/1. So if the slope is -3 on the top, that's your rise. So since it's negative, do you think you go up 3 or down 3? Well, it's negative, so you're going to go down 3. 1, 2, 3. Your run is a +1, so we're still going to go to the right. So there would be another point on that graph. You could do it again to get another point. So you go down 1, 2, 3, right 1. There's another point. And then we can connect those to get the graph of our line. So slope-intercept form of equation is in that form. You can see it's pretty easy to graph. Just make sure that you pay attention to which one's the slope and which one's the y-intercept. because sometimes they won't be written in that nice form. You might see it like 5 plus 1/6 x. Well, in this case, your slope isn't not the 5, it's the 1/6, because slope is always in front of the x. So this would be your slope, and your y-intercept would be 5. All right. So normally now we'd have time for questions, but since no one is here and active, I'm just going to move on to another way to graph, which is using Desmos, which is an awesome it's an online graphing calculator. You could also use a graphing calculator if you have a handheld one. But if you can go to Desmos, DESMOS.com, which I'm going to do that now, we can graph equations using that. So let me see. All right, so I'm going to share. This is my computer screen, so I'm at desmos.com. Pull up graphing calculator, and if you want to graph, if we went back to that equation, let me see the first one we graphed. Let's see, the y equals, so you type in y equals negative 3x plus 4. So you can see that it crosses at 4, 0, 4. Your slope is negative 3. So we go down 1, 2, 3, right 1, and you can see that point right here is on the graph. So 1, 1 is on the graph. From there, you could go down 3, right 1. You can see that's on the graph. So pretty cool tool. You could graph 2 equations on one if you wanted to see how they compare. So here's 2 lines. So notice they run parallel to each other, and that's because they have the same slope. I put in negative 3 for both of their slopes. The only difference is the first one crosses up here at 4, 0, 4, and the second one crosses at 2 because of what the y-intercept is. So this is kind of fun to play with to see how graphs change as you change their slope. So let's say I put my slope at positive 3. So now notice how that changes the graph. Now it slopes upward. So on my next session, we'll look at graphing inequalities. So when we have a less than or equal to. So something like that where you shade. So we'll look at that next time, but you can basically graph any equation on this. So just go to desmos.com, type in your equation, and see what pops up. All right, thanks for taking the time to watch this. Hopefully you learned a little bit more about graphing lines. There's multiple ways you can graph lines. You can use table, you can use slope-intercept form, you can use a graphing calculator, and so on. So again, thanks for watching and have a good day.